The warehouse in Kummersdorf sat quiet on the morning of January 12, 1943. Outside, snow covered the proving grounds where the German army had tested tanks and artillery for 2 decades. Inside, beneath harsh electric lights, 3 engineers from the Heereswaffenamt, the Army Weapons Agency, stood around a small, boxy vehicle painted in olive drab. It had been captured 6 weeks earlier in North Africa, pulled from a wadi near Sidi Bouzid after its crew abandoned it during a hasty retreat. The recovery team had towed it back behind German lines, intrigued by its odd appearance. It was smaller than a Kubelwagen, simpler than anything they'd seen, and yet American forces seemed to have thousands of them. Now it sat in Germany's premier military research facility, about to be dissected. Hauptmann Ernst Schneider, a mechanical engineer who had designed components for the Panzer Mark IV, walked slowly around the vehicle. His boots echoed on the concrete floor. He carried a clipboard and wore the grey-green uniform of the Wehrmacht Technical Services. Beside him stood 2 civilian engineers from Daimler-Benz, men who had spent their careers perfecting automotive excellence, who understood that a proper military vehicle required precision, robust engineering, multiple redundancies. They had come expecting to confirm what everyone in the Reich already believed, that American equipment was crude, mass-produced garbage, the product of a nation that valued quantity over quality, that built everything quickly and cheaply, because Americans themselves were soft, undisciplined, incapable of the engineering rigor that German industry represented. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Schneider placed his hand on the vehicle's hood. The metal was thin, stamped steel, perhaps 1/16 of an inch thick, a good strike with a rifle, but would dent it. He opened the hood and stared at the engine. It was a 4-cylinder inline motor, flat head design, displacing 134 cubic inches, crude cast iron block, simple valve train. Everything about it looked agricultural, like something that belonged on a farm tractor, not a military vehicle. One of the Daimler engineers, a man named Friedrich Weber, actually laughed. This is what they bring to fight the Wehrmacht? Mein Gott, look at this engine. We built better motors in 1930. But Schneider didn't laugh. He was counting the parts, counting the fasteners, counting the number of different bolt sizes. His expression grew more serious with each count. He moved to the transmission, a simple 3-speed manual with a 2-speed transfer case. He examined the suspension, leaf springs front and rear, the most basic design imaginable. He looked at the wheels, stamped steel, not even proper spoke wheels. Everything about this vehicle violated every principle of German engineering, and yet Schneider pulled out a specification sheet that intelligence had compiled from interrogations and captured documents. This vehicle, the Americans called it a Jeep, a name apparently derived from the military designation GP for general purpose, had been produced in staggering numbers. The sheet claimed over 100,000 had already been built, with production accelerating. Ford and Willys Overland, 2 companies, churning them out in multiple factories. He looked back at the Jeep. A question formed in his mind, one that would haunt German military leadership for the rest of the war. How could something this simple, this crude, this fundamentally wrong by every standard of proper engineering, be winning? To understand what those engineers saw when they examined that Jeep, one must understand the philosophy that governed German military manufacturing in 1943. It was a philosophy born from tradition, from pride, from a belief system that equated complexity with superiority. German engineering had dominated Europe for decades before the war. Mercedes-Benz produced the world's finest automobiles. Zeiss crafted optical instruments of unmatched precision. Krupp forged artillery that set global standards. This wasn't propaganda. This was measurable reality. A German camera lens truly was sharper. A German machine tool truly did hold tighter tolerances. German craftsmen trained for years as apprentices before they were considered qualified. This excellence created a national identity. Germany saw itself as the land of Dichter und Denker, poets and thinkers, but also of engineers and scientists. The periodic table was partly organized by German chemists. The diesel engine was German. Rocket science, jet engines, synthetic materials, Germany led in all of these fields. This wasn't empty boasting. These were facts. When applied to military equipment, this philosophy produced vehicles like the Kubelwagen, Germany's equivalent to the Jeep. The Kubelwagen was designed by Ferdinand Porsche, a man who would become legendary in automotive history. It featured a rear-mounted air-cooled engine, independent suspension on all four wheels, and a body shaped by aircraft designers to minimize weight while maximizing strength. It was clever. It was sophisticated. It was German. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. But the Kubelwagen required skilled labor to build. Its air-cooled engine demanded precise machining. Its independent suspension used intricate swing axles and reduction gears. Each vehicle took hundreds of man-hours to assemble. Quality control was rigorous. Components were inspected, measured, tested. Nothing left the factory unless it met specifications. This approach extended to everything Germany built. The Tiger tank mounted an 88mm gun of devastating accuracy and power, but each Tiger required 300,000 man-hours to produce. Its engine was a 23-litre V12 masterpiece that developed 700 horsepower. But it needed skilled mechanics to maintain and guzzled fuel at catastrophic rates. The Tiger was nearly invincible in combat. Germany built fewer than 1,400 of them in the entire war. The German military believed this was the correct approach. Wars were won by superior soldiers using superior equipment. One Tiger could destroy 5 American Sherman tanks. One Messerschmitt Bf 109 could shoot down multiple Allied fighters. One German division, properly equipped and trained, could defeat 2 or 3 Allied divisions. Quality would triumph over quantity. This belief was reinforced by early successes. In 1940, Germany had conquered France in 6 weeks. In 1941, German armoured spearheads had driven 500 miles into the Soviet Union in the war's first month. The Blitzkrieg worked. Speed, violence, and superior equipment had overwhelmed numerically larger enemies. The Wehrmacht had proven the concept. Why would they change? By 1943, when that jeep arrived at Kummersdorf, Germany controlled territory from the Atlantic coast to the Volga River, from Norway to North Africa. The Reich had conquered 2 continents. It had done so with armies that, man for man and machine for machine, were superior to anything their enemies fielded. The German soldier was better trained, better led, and better equipped. This was simply true. So when Hauptmann Schneider and his colleagues examined this crude American vehicle, they did so with the absolute confidence that German engineering philosophy was correct, proven by victory after victory. The Jeep, with its primitive engine and stamped steel body, was exactly what they expected from America. Quantity without quality, production without pride, vehicles built by a nation and that didn't understand warfare. Schneider began his examination systematically, the way German engineers approached everything with methodical precision. He created a form with categories: engine, transmission, suspension, electrical system, body, overall assessment. Each category would receive detailed measurements, part counts, and quality ratings. The engine came out first. 4 men lifted it from the chassis. It weighed barely 400 pounds and placed it on a workbench. Schneider disassembled it completely, laying each component in organized rows, connecting rods, pistons, crankshaft, camshaft, valves. He measured everything with German calipers and micrometers, instruments accurate to thousandths of an inch. What he found was startling not because it was sophisticated, but because it was so deliberately simple. The engine block was a single iron casting with no separate cylinder sleeves. The crankshaft ran in just 3 main bearings, not the 5 or 7 found in German engines. The camshaft sat directly in the block, without separate bearing inserts. Everything was designed to be cast, not machined. Weber, the Daimler engineer, pointed out each shortcoming. "Look at this crankshaft. No counterweights. The vibration must be terrible, and these pistons cast aluminum, not forged. They'll fail under sustained high RPM. But Schneider was looking at something else. He was counting fasteners. The entire engine used only 7 different bolt sizes. 7. A comparable German engine used over 30 different specifications. He examined the oil filter, a simple cartridge that could be changed in seconds. German engines used complex filtration systems requiring partial disassembly to service. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The carburetor was a revelation. It was a single-barrel unit, crude but accessible. Schneider could see how it worked just by looking at it. No hidden passages, no complex linkages. He timed himself disassembling it, 4 minutes. Reassembly, 6 minutes. A comparable German carburetor required specialized tools and training. He'd seen mechanics spend an hour adjusting them properly. The electrical system was equally crude. The generator produced just 30 amps. The battery was a standard 6-volt unit, but everything was mounted externally, easily accessible. Every wire was color-coded, and a simple diagram was stamped on a metal plate riveted to the firewall. A diagram, as if the designers assumed the mechanics would be incompetent, needing pictures to understand what connected to what. It was almost insulting. German vehicles came with detailed manuals, yes, but they assumed the mechanic had proper training. They assumed expertise. This Jeep assumed nothing. It was designed for idiots. Schneider moved to the transmission and transfer case. Again, brutal simplicity. The gears were cut rather than ground, leaving visible tool marks. German gears were ground smooth after cutting, then often lapped for final precision. These gears looked agricultural, but they were also large, overbuilt, with thick teeth that could absorb tremendous shock loads. The transfer case offered a 2-speed reduction, giving the Jeep exceptional low-range torque, but the mechanism was so simple, just a sliding collar and 2 gear sets, that Schneider could see exactly how it functioned. No complex planetary gears, no intricate dog clutches. A farm boy could understand this by looking at it. By the end of the first day, Schneider had filled 20 pages with notes and measurements. The other engineers had grown bored and left. This was beneath them, examining American garbage. They had proper work to do, real engineering projects that mattered. But Schneider stayed, because with each measurement, each part counted, each system analyzed, a disturbing picture was emerging. This vehicle wasn't crude because American engineers were incompetent. It was crude because they had designed it to be crude. Deliberately. Intentionally. Every simplification was purposeful. Every reduction in complexity was calculated. And if that was true, it meant the Americans understood something about war that Germany had missed. Something fundamental. Something that might explain why, despite German superiority in engineering, despite victories across 2 continents, the war was beginning to turn against them. Schneider spent the second day focused entirely on production analysis. This was the aspect that troubled him most. He requisitioned intelligence files on American automotive manufacturing, compiled from pre-war industrial surveys, reports from German businessmen who had visited Detroit, and recent analyses of captured equipment serial numbers. The Jeep before him bore a serial number indicating it was manufactured by Willys Overland in Toledo, Ohio, in November of 1942, but intelligence indicated Ford was also building identical vehicles at plants in Michigan and New Jersey. 2 companies, multiple factories, producing the exact same vehicle to interchangeable specifications. Schneider knew what this meant. The Americans had standardized everything. Every bolt, every bracket, every wire clip was identical, regardless of which factory produced it. Apart from a Willys Jeep would fit perfectly on a Ford Jeep. This was mass production at a scale Germany had never attempted. He pulled production figures from the intelligence files. In 1941, Willys and Ford together had produced 48,000 Jeeps. In 1942, the number jumped to 159,000. Projections for 1943 estimated over 250,000. These weren't estimates from Allied propaganda. These were German intelligence calculations based on shipping manifests, factory size assessments, and serial number analyses. Schneider did the mathematics. Assuming 300 working days per year, American factories were producing over 800 Jeeps per day. Per day. He looked at the vehicle before him, complex enough to be functional, simple enough to build in hours rather than days. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. He compared this to German production. The Kubelwagen, by contrast, was built at a rate of approximately 14,000 per year across all factories. The Americans were producing 18 times more light vehicles. 18 times. And this was just one vehicle type. Intelligence reports indicated similar production ratios for trucks, tanks, aircraft, and ships. But Schneider dug deeper. He examined the Jeep's parts individually, considering manufacturability. The body was stamped steel, made from simple dies that could be operated by semi-skilled workers. Forming these panels required large presses, yes, but once the dies were made, production was fast. A German equivalent would have been hand-formed or required multiple complex stampings, welded together. The frame was 2 parallel channel sections, cross-braced, simple to cut, simple to drill, simple to weld. No complex curves, no compound angles. A basic welder could assemble this in an hour. The German equivalent featured tubular construction with carefully calculated stress points, requiring skilled craftsmen to achieve proper alignment. The suspension mounting points were crude but robust. The spring shackles were heavy steel forgings, over-engineered for strength. They looked agricultural because they were designed like agricultural equipment built to survive abuse by inexperienced operators. German suspensions were more sophisticated, yes, but they required adjustment and maintenance. These leaf springs required nothing. They either worked or they broke, and breaking them took extraordinary abuse. Schneider examined the wheels and tires. The wheels were stamped steel, 3 pieces welded together. Crude, but stampable on massive presses at high speed. The tires were bias ply, size 7 to 100 by 16, nothing special. But intelligence indicated the Americans had standardized this size across multiple vehicle types. The same tire that fit the Jeep also fit certain trucks. This meant simplified logistics, interchangeable spares. He moved to the engine again, this time analyzing it from a production standpoint. The cylinder block was a single iron casting. One piece, poured in a mold, cooled, then machined. The machining required only basic operations, boring the cylinders, facing the deck, cutting the valve seats. Any machine shop could do this work. The cylinder head was another simple casting. The manifolds were cast iron, not fabricated steel. Every component was designed for mass production. Nothing required hand-fitting. Nothing required adjustment by skilled craftsmen. The entire vehicle could be assembled by workers with minimal training, using basic tools. The Americans had even designed special wrenches combination tools that fit multiple fastener sizes, reducing the number of tools required. Weber had dismissed this as evidence of American incompetence. They designed for their workers' stupidity, he'd said. But Schneider was beginning to see it differently. The Americans weren't designing for stupidity. They were designing for scale. They were designing for an entirely different kind of war than Germany was fighting. He pulled out his notes from a lecture he'd attended in 1941, given by a Wehrmacht logistics officer. The officer had calculated that Germany could sustain approximately 3 million men in the field with existing industrial capacity. This assumed normal attrition rates, standard equipment replacement schedules, and the full output of German factories plus occupied territories. The Americans, according to that same officer, could theoretically field similar numbers, but their equipment would be inferior, their logistics would be strained by the Atlantic crossing, and their soldiers would lack German training and discipline. Quality would defeat quantity. Schneider looked at the Jeep. What if the assumptions were wrong? What if the Americans could produce equipment faster than Germany could destroy it? What if simplicity was actually strategic? On the 5th day of examination, Schneider compiled his findings into a formal report. Standard practice required him to submit it through channels to the Heereswaffenamt Technical Directorate, where it would be reviewed, summarized, and filed. But something about his conclusions troubled him enough that he requested a meeting with General Major Wilhelm von Thoma, who had recently returned from North Africa and was consulting on armoured vehicle development. Von Thoma agreed to visit Kummersdorf on January 19, 1943. He arrived in the afternoon, a tall man with a scarred face and the Knight's Cross at his throat. He'd commanded Panzer units in Poland, France, and Russia before being sent to Africa. He'd been captured by the British at El Alamein and recently repatriated in a prisoner exchange due to his injuries. Schneider presented the jeep and his findings in a conference room adjacent to the workshop. Von Thoma listened without interrupting, smoking cigarettes and studying the photographs and specifications Schneider had prepared. When Schneider finished, von Thoma was quiet for a long moment. Then he spoke, and what he said was not what Schneider expected. "I have ridden in these vehicles," von Thoma said quietly. "The British captured hundreds in North Africa. They love them. Their officers use them constantly. I was transported to the prison camp in one." He paused. "In 2 years of combat, I never saw one broken down at the side of the road. Not one." If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. He stood and walked to the jeep, placing his hand on the same hood Schneider had touched days earlier. "Do you know what I saw in Africa, Hauptmann?" "I saw British supply columns that stretched to the horizon. Trucks, thousands of trucks, all running, all moving. American trucks, most of them. I saw airfields where the British had more petrol in drums than we had in all of Rommel's army." Von Thoma turned back to Schneider. "We kept destroying their equipment. We would overrun a position and find it abandoned, filled with supplies. Ammunition, food, water, fuel, medical supplies, all left behind because they had so much more coming. We thought we were winning because we were destroying their equipment, but we were not winning. We were drowning." He picked up Schneider's report, flipping through the pages. "Your analysis is correct. This vehicle is crude. But I will tell you what it is not. It is not unreliable. It is not difficult to repair. It is not rare. In North Africa, the Americans and British had these vehicles in such numbers that they used them for everything: reconnaissance, supply transport, ambulances, gun tractors, command vehicles, even fighting vehicles with mounted machine guns. We had the Kubelwagen, which is superior in every technical measure, but we had thousands. They had tens of thousands. When one of theirs broke, they pushed it aside and took another. When one of ours broke, we spent hours repairing it because we had no replacement." Schneider felt something shift in his understanding. "Herr General, are you saying that their approach is superior?" "I am saying their approach is different, and we have not adapted to it." Von Thoma sat down heavily, suddenly looking very tired. German manufacturing is designed for a European war. Short, decisive campaigns, quality equipment maintained by skilled mechanics. We win the initial battles with superior training and machines. Then we consolidate, refit, and prepare for the next campaign. He gestured at the jeep. "The Americans are not planning a European war. They are planning an industrial war, a war of attrition where victory goes not to the most skilled, but to the side that can sustain losses and continue fighting. They are building equipment that any fool can operate and any half-trained mechanic can repair. They are building it in such quantities that losses are irrelevant." Schneider absorbed this. "And we cannot match their production?" Von Thoma shook his head. "We are already stretched to maximum capacity. Every factory in Germany and occupied Europe is working around the clock. We are conscripting workers from conquered territories. We are using prisoners of war. We are stripping captured equipment for parts. And still we cannot produce enough." He stood to leave, then paused at the door. "Complete your report, Hauptmann. Make it thorough. Send copies to every relevant office. Perhaps someone will listen. But I suspect they will not. Germany has convinced itself that quality defeats quantity. We have proven it in battle after battle. Why would we change? But you believe we should change? Von Thoma looked back at the jeep one final time. I believe we should understand what we are facing. The Americans are not sending their best equipment to fight us. They are sending their most producible equipment. There is a difference, and if we do not grasp that difference, we will lose this war. After von Thoma's visit, Schneider expanded his investigation. He requisitioned every intelligence file available on American industrial capacity. What he discovered was more troubling than the jeep itself. The jeep was merely a symptom of a larger strategic reality that Germany had systematically failed to understand. The files contained pre-war assessments of American manufacturing capability, compiled by German military attachés and business representatives who had visited the United States in the 1930s. These reports were detailed, accurate, and alarming. They documented industrial facilities on a scale that didn't exist in Europe. Ford's River Rouge complex in Michigan encompassed over 2 square miles of factory floor space. It had its own steel mill, glass plant, and power station. At peak production, it had employed 100,000 workers building automobiles. One factory complex, 100,000 workers. Willow Run, a new bomber plant built by Ford outside Detroit, was documented in 1942 intelligence updates. The building was 3,200 feet long, over half a mile and a quarter mile wide. It was the largest room under one roof in the world. Intelligence estimated it could produce one B-24 Liberator bomber every 63 minutes once fully operational. Schneider cross-referenced these reports with German production figures. The entire German aircraft industry, combining Messerschmitt, Focke-Wulf, Heinkel, Junkers, and every other manufacturer, had produced approximately 15,000 aircraft in 1942. American estimates suggested they would produce 47,000 in 1943. The disparity wasn't just in aviation. Ship construction figures were even more stark. American shipyards were producing Liberty Ship's 10,000-ton cargo vessels in an average of 42 days from keel laying to launch. Some yards had reduced this to under 30 days. Germany's entire merchant marine, built over decades, totaled approximately 4 million tons. America was adding over 8 million tons per year of new construction. But the most disturbing information came from tank production analyses. The Jeep examination had led Schneider to investigate American tank manufacturing, particularly the M4 Sherman. Intelligence reports indicated multiple factories producing Shermans: Chrysler's Detroit Arsenal tank plant, Fisher Body's Grand Blanc facility, Ford's plant at Dearborn, Pacific Car and Foundry in Washington State, and others. The Sherman was comparable to the Jeep in manufacturing philosophy. It was not the best tank America could design, it was the best tank America could mass produce. Its armor was adequate but not exceptional. Its 75mm gun was effective but not superior to German weapons. Its mechanical reliability was good but not outstanding by German standards. But America was building them in staggering numbers. Intelligence estimated over 20,000 would be produced between 1942 and 1944. Germany's entire Panzer force, including all marks and models from the beginning of the war through 1943, totaled approximately 38,000 vehicles. The Americans were approaching that number in a single tank model in 2 years. Schneider compiled a supplementary analysis comparing production philosophies. He titled it Strategic Implications of American Mass Production Methods. The core argument was simple. Germany and America were fighting different wars with different assumptions. Germany assumed wars were won by superior soldiers using superior equipment in decisive battles. This had proven correct in Poland, France, and the early Soviet campaigns. Germany had designed its military around quality-intensive training, sophisticated equipment, skilled support personnel. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. America assumed wars were won by overwhelming material superiority sustained over time. They were designing their military around quantity-simplified training, producible equipment, interchangeable parts, and personnel. Every American military vehicle was designed so that any soldier with basic training could drive it. Any mechanic with basic tools could repair it, and any factory with basic equipment could build it. The implications were profound. German forces had to preserve their equipment because replacements were scarce. This made German units cautious, conservative. American forces could afford to be aggressive because losses were replaceable. If an attack failed, they could refit and attack again, and again, and again. German logistics required skilled mechanics, specialized tools, and specific replacement parts. American logistics required warm bodies and basic wrenches. A German Panzer division that lost half its tanks needed weeks to refit, waiting for new tanks to arrive from Germany, hoping they arrived before the division was committed to combat again. An American armored division that lost half its tanks could be back at full strength in days, drawing from replacement pools that seemed inexhaustible. Schneider documented specific examples from North Africa. After the Battle of Kasserine Pass in February 1943, where German forces had mauled inexperienced American units, intelligence had tracked the American recovery. Within 3 weeks, the Americans had completely replaced their losses. New tanks, new trucks, new jeeps, all delivered by ship to North African ports, then moved inland. The units that had been shattered at Kasserine were combat-ready again before German forces could exploit their victory. The Wehrmacht, by contrast, had never fully replaced losses sustained in the 1941 Russian campaign. Divisions that started Operation Barbarossa with over 200 tanks were still operating with 70 or 80 tanks 2 years later. The replacements simply didn't exist. Schneider submitted his completed report on February 3, 1943. It totaled 87 pages, including photographs, technical drawings, production analyses, and strategic assessments. He sent copies to the Heereswaffenamt Technical Directorate, the Wehrmacht, Operations Staff, the Reichsministry for Armaments and War Production, and directly to General Major von Thommer's office. The response was swift and entirely predictable. Within a week, Schneider received a memo from his superior officer at the Heereswaffenamt. The tone was formal but unmistakably dismissive. The memo acknowledged the thoroughness of his technical analysis, but questioned his strategic conclusions. It stated that while American production capacity was noted, German intelligence had always been aware of American industrial potential. The memo emphasized that wars were won by soldiers, not factories, and that German tactical superiority had repeatedly proven decisive against numerically superior forces. The memo concluded by redirecting Schneider's efforts toward more pressing concerns, analyzing captured Soviet equipment, and assessing vulnerabilities in the new 34 tank. The Jeep analysis was filed and forgotten. But Schneider's report did reach one person who took it seriously. Albert Speer, the Reichsminister for Armaments and War Production. Speer had been appointed to the position in February 1942 after Fritz Toth's death. Unlike many in the Nazi leadership, Speer was a pragmatist who understood industrial realities. He had already begun restructuring German war production, attempting to rationalize manufacturing and increase output. Speer's office contacted Schneider in March 1943, requesting a meeting in Berlin. Schneider traveled to the Reichsministry, expecting a brief consultation. Instead, he spent 3 hours presenting his findings to Speer and a small group of industrial planners. Speer listened intently, taking notes, asking detailed questions about American production methods. When Schneider finished, Speer was quiet for a moment, then spoke with characteristic directness. "Everything you have documented confirms what I have been arguing for a year. Germany cannot win a war of attrition against the combined industrial capacity of America, Britain, and the Soviet Union. Our only hope is to maximize production efficiency, simplify designs, and pray that our tactical superiority buys enough time for political solutions." He gestured at Schneider's report. "I will use this. I will show it to the Führer, to Göring, to anyone who will listen. But I must be honest with you, Hauptmann, they will not believe it. They will say that German spirit defeats American materialism. They will cite our victories as proof. they will dismiss your analysis as defeatist. Speer proved correct. Hitler, when presented with evidence of American production superiority, responded with rage. He insisted that German quality would triumph, that American equipment was inferior, that American soldiers were cowards who would collapse under determined assault. He pointed to German successes in Russia, in North Africa, in the Atlantic. He demanded increased production through willpower and discipline, not through fundamental changes in manufacturing philosophy. Goering, the head of the Luftwaffe, dismissed the report entirely. He claimed his intelligence services had better information and that American production figures were exaggerated propaganda. When presented with photographic evidence of American factories, he suggested they were elaborate fakes, movie sets, designed to intimidate Germany. Only within Speer's ministry did Schneider's analysis have impact. Speer initiated several programs attempting to emulate American mass production methods. He pushed for standardization across vehicle types. He advocated for simplified tank designs. He argued for concentrating production in fewer, larger facilities using assembly line methods. But he faced constant resistance. The Wehrmacht wanted the Tiger and Panther tanks, sophisticated machines that required extensive manufacturing time. The Luftwaffe demanded advanced fighters with complex engines. Every service branch insisted that quality could not be sacrificed. Speer managed some improvements. German war production did increase through 1943 and into 1944, but he could never achieve the fundamental philosophical shift that Schneider's analysis suggested was necessary. Schneider himself was transferred to the Eastern Front in May 1943, assigned to a Panzer Division's maintenance battalion. The transfer was officially described as necessary for manpower needs, but Schneider suspected it was partially punishment for conclusions that embarrassed his superiors. He would spend the next 2 years watching German forces slowly ground down by exactly the material superiority he had documented. What Schneider had predicted in his report unfolded with mathematical precision across every theatre of the war. The Jeep he examined in January 1943 was merely the first ripple of a tsunami of American production that would ultimately overwhelm Axis forces. By the end of 1943, American factories had produced 640,000 Jeeps. The number that would eventually conquer 2 continents wasn't hyperbole, it was conservative accounting. By war's end in 1945, total Jeep production exceeded 640,000 units, with vehicles serving on every front where American and Allied forces operated. These vehicles became ubiquitous. Every American infantry division received 553 Jeeps as part of its standard equipment allocation. Armored divisions received over 600. Even non-combat units received them in abundance. The Jeep transformed military mobility in ways that sophisticated German vehicles never could, precisely because they were simple, reliable, and inexhaustible. In North Africa, American Jeeps equipped British long-range desert groups that raided German supply lines. In Sicily and Italy, they navigated mountain roads that German vehicles couldn't traverse. On D-Day, June 6, 1944, over 2,000 Jeeps landed on the beaches of Normandy in the invasion's first wave. Within a month, 40,000 had been delivered to France. The strategic impact was exactly what Schneider had calculated, but the Wehrmacht had refused to accept. American forces could sustain operational tempo that German forces could not match. When the U.S. Third Army under General George Patton advanced across France in August 1944, it moved so rapidly that German forces couldn't establish defensive lines. Patton's army covered 400 miles in 1 month, supplied entirely by truck columns that included thousands of jeeps carrying ammunition, fuel, and communications equipment. German forces, by contrast, struggled with mobility. Their logistics remained dependent on horses even in 1944. Over 80% of Wehrmacht transportation was horse-drawn. Panzer divisions could move quickly when they had fuel, but fuel was increasingly scarce. Supply columns moved slowly, vulnerable to air attack. When equipment broke down, repairs took days or weeks because replacement parts weren't available. The Jeep's reliability advantage proved decisive in ways Schneider had documented but couldn't fully predict. American maintenance records from the European theatre showed that Jeeps averaged over 10,000 miles between major mechanical failures. German Kubelwagens averaged less than 4,000. This meant American units spent less time on maintenance and more time on operations. It meant fewer vehicles were deadlined awaiting repairs. It meant the same number of vehicles could support more extensive operations. But the Jeep's impact went beyond pure logistics. It became a psychological weapon. German soldiers captured in France and Germany during 1944 and 1945 consistently reported the same observation in interrogations. American forces seemed to have unlimited equipment. No matter how many vehicles were destroyed, more appeared. The steady stream of jeeps, trucks, and tanks created an impression of invincibility, of an enemy that could not be exhausted. This wasn't propaganda. This was material reality. American industrial production in 1944 reached levels that still seem fantastical. 4,000 tanks per month, 2,000 artillery pieces per month, 11,000 aircraft per month, 300 ships per month. And underlying all of this, 640,000 jeeps over 3 years, 98,000 Sherman tanks, 2 million trucks, 400,000 artillery pieces. Germany, fighting on multiple fronts, produced approximately 40,000 armoured vehicles of all types during the entire war. America produced that many Shermans in 6 months. The disparity that Schneider had calculated while examining one crude jeep in a warehouse at Kummersdorf proved to be the strategic reality that decided the war's outcome. The philosophical difference between German and American approaches became increasingly clear as the war progressed. Germany continued to develop more sophisticated weapons: the Tiger II tank, the Me-262 jet fighter, the Type XXI U-boat, each technologically superior to Allied equivalents. But these weapons arrived in insufficient numbers and too late to affect the war's outcome. America continued to refine rather than revolutionize. The Jeep received minor modifications through the war, but remained fundamentally unchanged. The Sherman tank was upgraded with better guns and armor, but kept the same basic chassis. American doctrine emphasized getting adequate equipment to the front in overwhelming quantities rather than waiting for perfect equipment in limited numbers. By 1945, when Germany surrendered, the material imbalance was staggering. Allied forces had complete air superiority. Allied armored forces outnumbered German forces 10-1 in most sectors. Allied logistics could sustain offensives indefinitely. Germany had been buried under exactly the avalanche of production that Schneider had warned about in his report 2 years earlier. Ernst Schneider survived the war. He was captured by Soviet forces in Poland in January 1945 and spent 4 years in a prison camp before repatriation to West Germany in 1949. He never returned to military engineering. Instead, he took a position with a civilian automotive manufacturer, working on commercial truck designs until his retirement in 1971. In his personal papers, preserved after his death in 1986, was a battered copy of his original Jeep analysis report. He had kept it through the war, through imprisonment, through the difficult post-war years. In the margins were handwritten notes added over decades, tracking how his predictions had materialized. Next to his calculation of American Jeep production, he had written, "Final total, 641,154. I underestimated." Next to his analysis of American industrial advantage, he had written, "We knew, we documented it, we refused to believe it." The Jeep that Schneider examined in 1943 was eventually destroyed during an Allied bombing raid on Kummersdorf in 1944, but its influence lived on in unexpected ways. After the war, access to Schneider's report and similar technical analyses influenced European automotive design. The philosophy of simplicity, reliability, and producibility that the Jeep embodied began appearing in civilian vehicles. The British Land Rover, introduced in 1948, was directly inspired by wartime Jeeps that British forces had used and admired. Its designers deliberately pursued simplicity over sophistication. The vehicle used a ladder frame, leaf spring suspension, and a simple 4-cylinder engine. It became one of Britain's most successful automotive exports. In Germany, the post-war Volkswagen Beetle's success owed much to lessons learned from American mass production methods. Ferdinand Porsche, who had designed the complex Kubelwagen, applied simpler philosophies to the Beetle. The vehicle was designed for manufacturing efficiency, with stamped steel body panels, minimal parts variation, and assembly methods that required limited skilled labor. It became the best-selling car design in history. The broader strategic lessons from Schneider's analysis were studied extensively in post-war military colleges. The report became a case study in how institutional bias can blind organizations to inconvenient truths. German military leadership had possessed accurate intelligence about American industrial capacity. They had documented it, analyzed it, and then dismissed it because it contradicted their fundamental assumptions about warfare. This cognitive failure wasn't unique to Germany. Similar patterns appear throughout military history. Organizations that ignore evidence that contradicts established doctrine, that dismiss threats that don't fit expected patterns, that cling to comfortable beliefs despite contradictory data. The Jeep itself entered legend. After the war, surplus military Jeeps flooded civilian markets worldwide. They appeared in European farms, African missions, Asian villages. Their ruggedness and simplicity made them ideal for developing regions. In many countries, Jeep became a generic term for any small four-wheel drive vehicle, like Xerox for photocopiers. The civilian Jeep, introduced by Willys Overland in 1945, spawned an entire category of vehicles. The concept of a simple, capable, go-anywhere vehicle proved so appealing that it survived long after military utility vehicles evolved into sophisticated machines. Modern Jeeps bear little mechanical resemblance to the one Schneider examined, but they descend directly from that design philosophy. Adequate capability, broad accessibility, personality over perfection. The strategic lesson that wars of attrition favor producibility over perfection has shaped military procurement ever since. Modern defense planners explicitly balance capability against manufacturability. The question isn't just, is this the best weapon? But, can we build enough of them? Yet the lesson is repeatedly forgotten. Military services still push for exquisite, expensive, technically sophisticated equipment, when simpler, cheaper, more numerous alternatives might serve better. The debate between quality and quantity, between the Tiger tank and the Sherman tank, between the Kubelwagen and the Jeep, continues in modern form with fighter jets, ships, and armored vehicles. Schneider's report ended with a conclusion that proved prophetic. The American vehicle examined represents not inferior engineering, but different priorities. Where German design pursues excellence, American design pursues sufficiency. Where German manufacturing emphasizes precision, American manufacturing emphasizes volume. These are not weaknesses to exploit, but strengths to fear. A war against American industrial capacity cannot be won through superior equipment. It can only be avoided. Germany did not avoid it. The Reich that had conquered 2 continents with sophisticated equipment and superior tactics was ultimately crushed by simpler equipment produced in overwhelming quantities. The Jeep that Schneider examined in that warehouse at Kummersdorf was a messenger delivering a warning that Germany could not, would not accept. By the time the full implications became undeniable, it was far too late. 640,000 Jeeps, 2 million trucks, 98,000 tanks, 400,000 aircraft. This was the avalanche that buried the Third Reich. It began with one crude, simple, deliberately unsophisticated vehicle that German engineers examined and dismissed. In that dismissal lay the seeds of strategic defeat. The Americans had understood something fundamental. In total war, adequate equipment that exists defeats perfect equipment that doesn't. The Jeep proved it, 640,000 times over. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.